Okay, maybe we will give folks another 2 minutes to join the call and fill out the poll. As people are kind of trickling in, I'm going to do a few housekeeping messages, and then we'll sort of transition into the tutorial proper. So if you don't know me already, my name is Rebecca Bilbrow. I'm so happy that you're here. And I just want to start by saying, whatever experience level you're at, you belong here, right? So we're gonna do our best to meet you where you are, and wherever you are is great, and we'll go from there. So in terms of housekeeping, we do have kind of a chat functionality that, and also there's a Q&A option. You're welcome to use either. Prema Roman is going to be our instructor, so she's going to be sharing her screen and sharing slides. And so my plan is to serve as the teaching assistant. And so I'll be watching the chat and the Q&A. And if something comes up that's like a troubleshooting thing or a small question, I'll probably respond to it just in real time. No pun intended. And if there's anything that's sort of more to what Prema is speaking to, I think Prema is planning to pause periodically throughout the tutorial so that she can take your questions. So there will be, this can be interactive if you want it to be. If you just want to observe, that's fine too. Whatever you're comfortable with is fine. The recording, we are recording, and the recording will be made available after the webinar. And so if you're kind of on your lunch break and you actually need to go and eat and you need to drop off a little bit early, we'll circulate the recording. Also, if you have questions after the webinar, so if you're still working on getting your machine set up to run the tutorial code for today, and you don't want to kind of worry about it too much during the actual tutorial, and you want to worry about it later, if you run into any issues, you have my contact information, you have Prema's contact information and Becky's contact information, so you can reach out to any of us and we can help troubleshoot. So I think that's all of the housekeeping stuff. So just a quick mention, we all work at a company called Rotational Labs. Rotational Labs is a distributed systems company, but our goal is really about making it easy to navigate data across space and time. Prema is going to kind of show one example of that today, which is interacting with data feeds that are real time. So the data is kind of streaming through. She is an expert. She's a distributed systems engineer at Rotational. Her specialties are machine learning and MLOps. She's also one of the core maintainers and core contributors of the popular Yellowbrick library that you might be familiar with if you do machine learning. And the tutorial that she's going to give today is geared at trying to help people move from thinking about doing analytics and doing data ingestion and processing in a batch-wise fashion into doing it in a streaming fashion, potentially for even just a few use cases. A lot of us, and I know this, in my own training, I was trained to kind of think about data as something that accumulates in a database, and then only after it has accumulated to some degree, then I can do analytics. And that's true. There's certain kinds of math that you can only do if you have a lot of rows, like take an average, let's say. But there's a lot of other things you can do to an actual stream of data, as you just have, single events coming through. You can do a rolling average. You can compute outliers. There's all kinds of things you can do if you kind of move beyond this batch-wise model of thinking. But it's tricky because it's not what most of us get trained to do. So I'm going to turn it over to Prema Roman, who is going to help us kind of take those initial steps beyond the batch. Prema?
All right. Well, hello, everyone. I'm so glad you could join us today. I'm very excited to talk to you about building real-time data applications. I'm sure that a number of you are already aware that there are several solutions out there in the market that you can use to build real-time data applications. But for those of us who come from a traditional relational database background, as Rebecca mentioned, making that switch, from a batch process to building streaming data solutions, has not been intuitive and has been fraught with complexities. So we here at Rotational Labs built Ensign specifically to address these pain points. And before I dive into the example code, I want to kind of show you a brief overview of comparing Ensign to traditional relational database so that you can make the switch from thinking in batches to thinking in streams. So with that, I'm going to share my screen here real quick. So here you can see kind of traditional database concepts on the left and Ensign on the right. And so just as we have the database, a similar concept in Ensign is projects. And a project is simply a collection of related data sets that serve a business use case. And just as databases consist of tables, projects consist of topics. But there is a key difference, and that is that a table consists of the most recent state, versus in a topic, all the objects that are in a topic get stored, all the changes to those objects get stored, and they get stored in chronological order. So what does that mean? That means that tracking data changes over time is a lot more seamless. And then similarly in Ensign, managing data access for your teammates within an organization is much simpler. You don't have to deal with complex IAM policies as you do with cloud providers. Ensign also has a concept of tenant, which is kind of analogous to environments, basically the environment that you're working on, such as dev, prod, or staging. And so now that we have kind of this overview of comparing Ensign to traditional relational databases, I will go ahead and show you kind of the code for one of the examples that we have here. And so, as Rebecca mentioned, a lot of us kind of started out, as data engineers. And if you kind of think about, what data engineers, are typically, responsible for sourcing, ingesting, transforming, and moving data across an organization. And they have a lot of responsibilities. So they have to manage, all the databases, they have to manage all the ETL, and then they have to deal with data access, and then also have to deal with PII. And a data engineer's job is not easy. If you kind of think about it, data is inherently messy. You have to deal with missing records, duplicate records, mixed data types, and all sorts of surprises. And then on top of that, tracking data changes can be really complicated. And so the end result of all of that is that companies are not able to realize the full value of the data that they own. And data engineers are often frustrated because a lot of their time has to be spent on managing existing processes and putting out fires, and doing a lot of manual work to address these problems, when they could be spending that time working on exciting new projects. But imagine if operationalizing data is not so complicated. Imagine if giving access to your teammates is not as complicated, and if you didn't have to worry about users bringing down your database or deleting data by accident. And so with this example, what I want you kind of start thinking about is how all of this can be actually a lot more streamlined, and as you kind of take away from the architecture design in this example to see how all of those pain points can be addressed. So kind of, before I start with the example, I don't know, Rebecca, if there's any specific questions that, people had about, kind of just the overview and, some of the things that we talked about so far.
So, right, I don't see any questions yet, but if anybody has questions about kind of the concept of sort of data routing, or maybe anything related to either the prerequisites or the setup here, feel free to drop me a note in the chat or in the QA, and I'll keep an eye on it, Prema.
Awesome. All right, so so in this particular example, we're going to use Ensign and Watermill. And Watermill, for those who aren't aware, is a Go library that provides a unified API to work with event-driven streaming data solutions, so such as Kafka and Google PubSub, and then now also with Ensign. And what it really does is it helps you rapidly prototype event-driven applications, such that like if you start with say like one solution, you can actually port that over to another solution. And then they also have a lot of like examples, like they've really thought about a lot of the kind of common things that you would use an event-driven solution for. So whether it's for data streaming or if it's kind of like for for acting on messages and things like that. So it's actually pretty easy API to use. And I also actually wrote a blog post about it to kind of give an introduction to Watermill, and I highly recommend that you read this post to kind of get more familiar with it. And so before I kind of dive into like the specific sections of the code, I want to kind of give you an overview of the ETL design. And what it will show you is that even though like we are kind of talking about ingesting, data from an API and inserting into a database, which sounds like a pretty simplistic example, the way this architecture is designed lends itself to a lot more flexibility that makes things a lot less kind of painful to implement. And so with that, kind of at the high level, this weather ingester is composed of three components. So the first component is an Ensign publisher that calls the weather API and publishes the weather data to a topic. So kind of like what we talked about earlier with topics are sort of like your or like they're like your tables in a relational database. The second component involves an Ensign subscriber that listens on this topic and runs a check against a Postgres database to see if this is a new record. And the thing is that even though the weather API is like a real-time streaming API, and you'll get records as soon as you ask for it, the data doesn't change that often. So it is possible to get duplicate records. And so this subscriber does the work of checking to see if this record's already been inserted into the database. And if it hasn't, then it will publish this record to a second topic. And then we have this Watermill SQL publisher that will insert the record from that second topic into the database. So the one thing that I want to point out that is actually pretty elegant about this design is that if you imagine if there's any sort of failure in any one of these components, that doesn't result in a failure of the entire application. And I'm sure like a number of you who have kind of worked in data projects, the workflow typically is that you do all these sorts of complex transformations and all of these like different steps take a long time to run. So, but imagine like you have like the last step, where that process fails, and then now you have to basically go and like redo that that whole ETL process, and that imagine like that's cause for a lot of frustration. That is a lot of hours that you've spent trying to fix this problem. But here with this particular design, what you'll notice that is that say if the publisher goes down, that doesn't stop the subscriber from continuing to listen on the topic or the SQL publisher from going down. They're just going to wait for new data as it arrives. And really the end result there is that there's a delay in receiving the data. And so then you can just restart the publisher and it'll publish the data, once it's up and running, and then the subscriber, simply listening in on that topic, and it'll do its work. conversely, if the subscriber goes down, that doesn't prevent the publisher from publishing the messages to the topic, because it doesn't really, at this point, like doesn't care about like what the subscriber is doing. It's going to, simply just publish the data on the topic. And then the subscriber is pretty much like, once you actually bring the subscriber up, will consume, those new messages and do its work. So there's like one pain point that you're already kind of, addressing by designing the code in this fashion. So it looks like before I kind of go into some of the main components of this code, it looks like I think there's some questions. I don't know if there's something that you might want to address before I continue.
Yeah, actually, we had one question about kind of how Ensign compares to something like Kafka or PubSub. So maybe I can say just a little bit about that. Kafka is the original eventing tool. So it's the OG, it's the kind of the granddaddy of all of these other tools. And, it's been around for about 15 years. And it has a lot of usage. It is, it's 15 years old. So there have been a lot of innovations since that time. And so there are kind of other tools that are popping up that kind of do things that Kafka is not quite as good at. And Ensign is one of those. So one thing that makes Ensign special compared to something like Kafka or Google PubSub is that Ensign has persistence turned on by default, which means that your data doesn't go away. With PubSub, and Kafka, generally those tools, your data, automatically expires after about a week because they assume that you've already consumed it and that you don't need it anymore. But if you're doing like machine learning on your historic event data and you're trying to model things over periods of time, you kind of want the data to still be there after a week or so. And so Ensign allows you to persist that data as a stream. And so you can kind of keep doing your analytics on all historic data and all new data moving forward. But you can kind of use Ensign as a replacement for Kafka or PubSub. But more likely, you're just you're fitting it into some small use case, that you already have a database, you already have, a bunch of tools, and you just need to add maybe one small use case that supports kind of doing streaming analytics, let's say, and Ensign is designed to make it easy to kind of wedge that in so that you don't have to like throw away your whole architecture and start over, because that is not ideal.
In fact, actually, to what Rebecca mentioned, like you'll see with this example that you can still have your database and with storing all the data that kind of is your source of truth. But what you can do with this example is like still keep that and have kind of some use case where you're using Ensign to kind of offload some of the responsibility that you normally would use with a traditional database, and actually not have to worry about, say, users bringing down your database or giving access to users who otherwise might have been more complicated to do so.
Actually, I saw we just got another question. This is a very good question. What happens to the data that the publisher sent out while the subscriber was down? Will the subscriber lose out on receiving that data? And so this is an excellent question. It's a good follow-on to what we were just sort of saying at a high level about persistence. But the way that Ensign works is it's storing all of the data. So no data ever goes away unless you ask for it to be deleted. And so the publisher is, the publisher and subscriber are operating potentially asynchronously from each other. So they're kind of decoupled. You can have a publisher that's sending out data, and then whenever a subscriber wakes up and starts running, it can start consuming from whatever offset it wants. And so that offset could be from the very beginning. So the subscriber could sort of write a query, and actually this is probably going to look like a SQL query where it's like, return all events from the table, which is the topic, right? Return all of the events from the table starting at offset 0, which means go all the way back to the beginning. But if you have a subscriber that just died in the middle of the process, it can wake back up and resume from the offset that it was at when it went down. So you don't lose any data. And you can also have multiple subscribers who are running concurrently, right? So you can have, if let's say Prema and I are both subscribing to the same feed, we can subscribe at different offsets, right? We can start at different starting points, and we can both be consuming from the same publisher concurrently. So hopefully that answers that question. All right, I'm going to turn it back to you, Prema.
Right. So yeah, actually on a related note, I mean, as Rebecca mentioned, like you can have multiple subscribers that are, subscribing to that same topic. So imagine like you can actually have different teams, right? Essentially like, consuming that same data, and one team, might be interested in building a machine learning solution. Another team is interested in building a dashboard out of that data. And so really, like, I think with, the way we've designed Ensign, we're really going, like, I think it really helps, companies, with the potential of like democratizing data access, in ways it wasn't possible just because, there's this bottleneck with like, data engineers having to serve, multiple users. And so, as you see with this example, how it's going to be easy to do that. And so with that, let's dive right into the code. And so here's the first, we'll basically start with the first component where we're building the Ensign publisher. That will do the work of consuming, ingesting data from the weather API. And so the code is pretty straightforward. You're essentially instantiating a publisher by calling ensign.newPublisher. And then you have to pass in a publisher config. And then in the publisher config, you're basically setting these two parameters. And the first is called ensure create topic, and you set it to true. And now what this does is that you don't actually have to create the topic ahead of time. What this will do is that if the topic doesn't exist, it will create it for you. And then now what the publisher does is it's going to, once it gets the data, it's going to marshal it and send it across the wire, and to publish it on the topic. And so we need a marshaller. And in this case, we have this ensign.event marshaller that will, take care of, the work of marshaling this data and, publish it to the topic. And then before we call the weather API, we had to create a couple of structs. Essentially what these structs are going to be used for is to, parse out the response body that you get from, after you call the weather API. And so the first thing is we'll create the struct for the actual response itself. And so this, is going to match essentially like what the weather API sends back. And this response struct contains this data type called another struct called current. And then current has all this like information about the current, state of the weather, things like the temperature, the winds mile per hour. And then within current, it also has this another struct called current condition, which gives you the condition, like whether it's like rainy or windy, et cetera. And the one thing that you can do is like you don't actually have to take the actual current struct that's provided by the weather API has like a long list of like fields, and I just basically boil it down to like some key fields. And so you can kind of do the same thing, like, where if you're consuming kind of any other API, you don't have to actually take everything. If you want to, you can just, as long as you're kind of matching, what they provide to you, and you can take a subset of those fields. And so essentially what we will do after we define these structs is also create this additional struct called API weather info. And so here, one of the things that I'm doing here is basically changing some of the variable names to kind of, more, something more, relevant for like the table. So for example, like where they're saying, temp F, I wanted to convert it to temperature. And so basically combining, some of this information that's in these two structs into this one single struct that's going to be used to publish the message. And really what's going to happen here is that we'll send this, and these are going to match the fields in the table that we're going to store the data. Basically going to match the field names in the table where this data will be inserted into. And so next here, so this, you're basically going to create an HTTP request. And so this is going to be a GET request. This is the URL of the weather API. And then we will create a query object. And so, one of the environment variables that you need to set is the WAPI key, which is the key that you're going to use to call this API. And then I've added in this query parameter, the other parameter is the city for which you want the weather. So in this case, I've used Washington, DC, but you can, obviously pick another city, that you're interested in. And then, so we'll, create an HTTP client. And so this is kind of pretty much, if you're familiar with HTTP requests, this is pretty standard code. And then you'll receive, retrieve the response, and then get the response, the body of the request. And then we're going to unmarshal that body. And then we're going to unmarshal and basically get this response back. And then we will then use this response to populate that API weather info struct that we created earlier. And so this is how we do the translation, where we basically call current equals response.current. And then you have current weather info in the of type API weather info, where we say the last updated, set the last updated to current dot last updated, temperature equals current dot tempf, and so on and so forth. And so that's the part, that's basically creating this object that we're going to send across the wire. So now let's actually take a look at how to publish this data. And so for that, we'll create this function called publish weather data, and it's going to take in the publisher, and then this closed channel. So this is a watermill concept. And so the idea behind this closed channel is it's a channel on which, like, if a signal sent across this channel is going to, shut down the application gracefully. And what we're going to do basically is to create a ticker object, which is going to be used to call the weather API in a defined time interval. So in this case, I'm actually setting it to every 5 minutes, because even though you can call this weather API in real time, since the data doesn't change that often, it's it's fine to kind of call it in a shorter interval. But obviously, like, you can tweak this based on your use case. And so so as in each interval, we're basically going to first check if there's a message that's sent through the closed channel, it will stop the ticker, and then it'll start the process of shutting down the application. But if not, we'll basically run this get current weather, which is the function that we use to call the API, and we'll get back the weather data. And if you get the weather data back successfully, we will create a payload and basically just call JSON.marshal and pass in this weather data, and we'll create this payload. And if we create the payload successfully, we're going to create basically a new watermill message, and we will create a unique identifier associated with the payload. So this is sort of a way to kind of distinguish different messages from each other. And then Watermill actually also has this concept of middleware, which is basically kind of similar to HTTP middleware, where you can kind of do some action on every single message that you're publishing. And in this case, like, one of the middlewares that we're going to use is called set correlation ID. And what this correlation ID features, like, if you have, in some cases you might actually have some sort of like indirect like dependencies between the publishers and the subscribers. And if you want to do kind of like some kind of debugging between messages, you can kind of use the correlation ID to kind of correlate messages that the publisher published with the corresponding, like the consumption of that message. And then to publish, you simply call publisher.publish. And then this is the name of the topic that is going to publish to. And then we pass in that message, that we just created. And then here below, we have the orchestration script that puts everything together. And so we'll first start with, creating this watermill logger. And then, so you already saw this before, we're creating the Ensign publisher. And then we go to defer publisher.close. So basically, like earlier, we were talking about like how if, you get this signal to, shut down the application, this is how it will, close the application. And then we're going to create this, closed channel. And then we'll run this publish weather data in a, Go routine. So it's basically running in the background. So we pass in the publisher and this closed channel. And then, essentially in this demo, what like we actually run this code. One way to shut down the application is just to call Control-C. And so that's, going to send that SIGINT message, and then that will message to close the application. And then once the application shut down, then you have this message at the end, like, oh, all the messages have been published, if that's what you wanted to do. And so that's the first stream, kind of in a nutshell. Just wanted to pause here to see if there are any questions.
Thank you so much. So I did get a question. So this person is referring back to the, I think the table that you showed, or the illustration that you showed about the comparison between like the database view and the stream view. And they say, in the same way that like the idea of tables maps to the idea of topics, can I think about a publisher as the DBA who's writing, or the data engineer who's writing to the database tables or the topics, and the subscriber as like an analyst who's querying tables or topics? So that's an interesting question. I think the answer is yes, except that an analyst, with streams, an analyst could also publish to a new topic. Right. So if they've got insights, which I guess is what we'll see soon, if you can kind of derive insights from the data that's coming through, there's nothing to prevent a subscriber from also publishing data onto the same stream or onto a new stream if they are identifying insights on the fly. So yes, and also more.
Yeah, exactly. I mean, if you think like of a specific use case, you can have, say, a machine learning engineer who does create these new machine learning insights, and then it can publish these insights, and then say a Power BI developer can take those insights and then populate a dashboard with it.
Okay, I've got another question for you. Would you be able to speak more to the running average example? The idea that, maybe instead of, kind of querying a database for all of the weather data rows that you've pre-populated and trying to take, let's say, the average humidity. Instead, if you were going to do like a rolling average on an event stream, it seems like there is a concept of caching that might be here. The publisher publishes a message to the queue. The subscriber consumes the message. The subscriber references some cached data to understand the historical state or the running average, and accordingly updates the state. Am I thinking about this correctly?
Could you repeat that the last part?
Sure. So I think, the person asking the question is trying to get a sense of like what other state is necessary in order to execute something like a rolling mean between a publisher and a subscriber. So assuming that, Ensign is taking care of publishing the data and there's a subscriber who's consuming the events on the other side, what other state, is needed, let's say with the subscriber, in order to effectively compute that like rolling mean?
Right. I think so. Yeah, this is, because the fact that this is like a rolling mean, you would want at least like the previously computed rolling mean, so that then you're just going to pass in, rather than having to have, all of those previous records, you're just going to then basically do the computation on the new data that arrives, and then now compute the updated rolling mean. And so so the one, obviously, like the obvious benefit there is that computation doesn't take as long.
Yeah, and in a future tutorial, we might do an example where we're actually doing machine learning. This is something that Prema was actually experimenting with 2 weeks ago. But when you use a streaming approach to training a model, a machine learning model, it goes a lot faster. So the training is much, much faster, like maybe orders of magnitude faster. But hopefully that answers the questioner's query about kind of the state that's required. You can think about the subscriber as probably part of a larger application that's running, maybe a slightly larger application that's running. So it's some kind of script that's running, and that script has maybe like a global variable for rolling humidity average or rolling humidity value. And every time it gets in, the subscriber consumes another event, it can look at that global state, and take that last value and maybe the last, window of values and compute, an update if needed, or maybe, publish an alert if it looks like there's a big outlier, like if there's a huge humidity spike. In addition to kind of updating that mean, it could publish an alert to another topic or something like that, like watch out, roll up your windows, it's a high humidity day or something like that. Hopefully that answers the question. It doesn't look like we have any other questions right now, so I think you're good to go to proceed with the tutorial, Prema. Thank you.
All right. So next, let's talk about the Ensign subscriber. And if you look at this code snippet, what you'll notice is that it's actually very similar to creating the Ensign publisher. And so pretty much like here, what changes here is that you create the subscriber object and you set it to Ensign.newSubscriber instead of new publisher. And then you pass in a subscriber config. And then notice you'll still have this ensure create topic and set it to true. And then here, basically, because subscribers are going to take a message, from a topic, they have to unmarshal the message. And so we set up this unmarshaller and, set it to Ensign.event marshaller. And then, so because in this particular use case, we're actually going to be inserting data into a database, we have to, set up the database connection. And so we'll use a Postgres database. In this case, it's going to be a Docker container. And so we're going to set up the host, and we're going to call it WeatherDB. And this is going to be important because basically, if you look at the Docker Compose file, we set the container name to WeatherDB. So this way, we make sure that the, when we do insert, like it actually, connects to the correct, so that you can establish that connection. And then here's where we also, set up all the Postgres environment, variables. And, so you can, when you set up the environment variables, you can, pick any values of your choosing. And so long as you're, using these variables, you should be good to go. And so we're going to basically, in this code, we're going to, set up the database connection. And then we're going to, before we do the work of actually inserting the records in the database, we're going to create this query to, create the table. And so what you'll notice here is that it's got all those fields, that were in the API weather info object, but with the exception that we also add an ID column, which is the primary key, for the table. And then we also add this created at, to record when this record was inserted. And then so we'll execute this query. And then we're essentially going to be then passing this database connection so that the subscriber can use that connection to check to see if the records exist in the table. And then we'll also create a separate, a different struct that's similar to the API weather info struct called weather info. And the difference here between the other one is that we have this additional field called created at. And so essentially what's going to happen is that when we run that insert query, it's going to, we're going to populate this field as well, before that insert happens. And then we also have to create this DB handler struct, which is basically, it contains the database connection so that we can communicate with the database. And then that's used here in this checked record exists function. And so what that takes in as an input parameter is a watermill message, and then it will also output a list of messages. And then what we're going to do first is basically unmarshal that payload from that topic and convert it to this weather info object. And then the field that we're going to use in this object is the last updated, because that's what, like when the weather API sends these messages, if it's a new record, it will update that last updated field. Otherwise, that last updated stays the same. And so we're going to basically run this like select count star from, and so this is the table that we just created, where last updated, equals that value from that payload. And then if the count were greater than 0, which means like the record exists, then we won't do anything. But if the record doesn't exist, then we will create this new weather info object. We'll pass in all of those values, and then we'll add this created at and set it to the current timestamp. And then we will encode this object before we publish it to the topic, and then we'll take that encoded object and create a new watermill message, kind of similar to like what we did on the publisher side, and then we will return this message. And then next, we also need the watermill SQL publisher, because that's going to, once it's listening in on the second topic, and once it gets a new message, it has to do the work of inserting the record into the database. And so the way you do it, and you kind of see, there's a very similar pattern, right? So we're creating this new SQL publisher. We'll call it pub, and it's SQL.newPublisher, versus Ensign.newPublisher. We have to pass in that database connection, and then we're going to use the SQL.publisher config. And in this case, the Watermill SQL package has a few different adapters for Postgres and MySQL. And so in this case, because we're working with a Postgres database, we will use a Postgres schema adapter. And then this auto initialize schema, so basically like they provide a function that if you wanted to use, will create the schema for you. But we're going to set it to false because we did that work already. And we wanted to have it set up before the checking happens. And so we've set it to false. And then now, even though we're not going to actually, have the Watermill SQL package do the initializing that schema, we do need to still define this. We need to define this function. And so we're passing in this Postgres schema adapter, and this is the function that has to be defined, and it's called schema initializing queries. But what we'll do is just pass an empty, return an empty string, so it doesn't do anything. And then now let's take a look at the code that's going to do the actual, work of inserting the record. And so in this case, we have the topic, so the topic is to keep in mind is actually going to be the same name as the table in this database. And so it has to, they have to match. And then it will take in the message that was published on the topic, and then we'll return the SQL script basically that that's going to get executed, and it'll do the work of inserting the record into the database. And then so this is pretty kind of straightforward, like SQL query where you're inserting into this table with these values, and then so for each position we're going to be essentially replacing those parameters with this information that we get from that the weather info object. And so, but before we can do that, we need to decode decode that watermill message and convert it into this weather info object. And then we will essentially update, we'll take the weather info dot last updated, and then that will get replaced here in position 1, and then weather info dot temperature that gets updated in position 2, and so on and so forth. And so this is the query that will get executed when this function is called. And then now, so I've kind of shown you an example of using the Watermill SQL publisher. There's also the Watermill SQL subscriber, and what the SQL subscriber is doing, if you define one, is it's actually listening to new inserts into the database, and then it can do kind of any downstream work. And so this is where, and I kind of touch on this a little bit towards the end, is where you can have basically create these SQL subscribers that are going to like offload the work from the database, like where it'll just publish these new records into another topic, so that you have downstream users who are going to use that data for their use cases. So whether it's for machine learning or any kind of data analytics, and they can just subscribe to those topics and do the work without hitting your database directly. But now in this particular example, we are not going to use a SQL subscriber, but just like we have to define these functions. So one function is the select query. So this would be the select from this table when like the a new record gets inserted. But in this example, we're just going to return an empty string. And then as you can imagine, like if the subscribers have to like unmarshal message, so the other function that gets defined here is unmarshal message, and we're going to again like not implement this function because we're not actually using a SQL subscriber. And the offset, we'll set 0 for the offset, and then we'll set 0 for the message, and then essentially send an error saying that this is not implemented. And then last, we have this orchestration script that will run run this component. And so Watermill has a concept called router. So with this router, like you can add handlers, and kind of similar to how HTTP works. And the idea behind using the router in this example is that as you imagine, like it's got these two components that are sort of, even though they're loosely coupled, they have some dependencies on each other. And so what we're going to do is basically kind of chain those two components together using this router. And so the first thing we're going to do is define this router, which is basically calling this Watermill message module called message.newRouter, and then we'll pass in a router config. And then we'll add this plugin. And so what Watermill has a few plugins, and like this one, what this particular plugin does is like basically, as I was mentioning before, if you do a Control-C on your application, it will look for this like signal, it will send a sigterm message and it will shut down the application. And so we'll add this plugin called plugin.signals handler. And then we'll add, we'll also add a middleware to this router. And they one of the middleware that, another middleware that Watermill provides is the recover middleware, which helps recover from any kind of panic that happens on your application. And then the first thing we're going to do is create that Postgres connection, that we talked about before. Then we will create the subscriber, the Ensign subscriber, and then we'll create the SQL publisher, and we pass in that connection. And then we will add this handler that does the work of chaining the Ensign subscriber and the SQL publisher. And so the handler requires a unique name, and so we'll call it, weather info inserter. And then and then the next parameter here is the topic that the subscriber is listening to. And then next we pass in the next parameter is the subscriber, and this is the Ensign subscriber. And then next is the topic that the subscriber is going to publish to. And then we'll have the SQL publisher. And then we pass in the function that gets executed first when the message comes into this first topic. And so that's the check record exists function. So we're making sure that we're preserving that order in which these functions get executed. And then last, let's take a look at the Docker Compose file. That's basically the application as a whole. And so it has 3 services. So the first is the producer service. And so we're using a Golang image. And then, we'll set up the environments. In this case, we set up the, the weather API key, and then the Ensign client ID and the Ensign client secret. And then you have the consumer service. And the consumer service is going to, also have a Golang, image. And then we add these Postgres environment variables as well, because the consumer is going to connect to the Postgres database. And then we have this Postgres service, and as I mentioned before, the container name is the weather DB, and that's what we'll use to set up the database connection. And then here the environment variables, where you define to be able to connect to this container. And so that kind of much concludes like the setup of the whole application. And before I do the demo, just wanted to see if there are any questions.
We do have a few questions. So the first one is, can I use something like the SQL subscriber to publish events from any Postgres database into a topic?
Yes, absolutely. And so that's where, wanted to show you, some of the potential use cases that this actually opens up, right? And we're talking about all the concerns that we've had or have experienced with multiple users hitting our database and potentially bringing the database down, or somebody who comes in and accidentally runs a drop table and deletes the data. Now, what you can use the Watermill SQL publisher to basically have or the subscriber that's actually just listening in on new records from your database, and because those records are offloaded from the database into this topic, they can just simply consume those records from that from that topic, and they're not hitting your database directly. And then they can pretty much manage what they do with that data from there. But then the other kind of exciting thing that this opens up is that there's always this concern about oh, you don't want people to mess up with production quality data. And then so oftentimes the pattern has been, let's use mock data to prototype our applications. And then when you make the switch to a production system working with production data that you've never seen before, there's all sorts of surprises that happen. And now you don't have to deal with any of that. You can just have your users using production data right off the bat, so that all of those surprises are addressed ahead of time.
Thank you. Okay, another question. How does Watermill return errors to the user? In other words, how do I know from the publisher perspective if events were actually published or if they were dropped and I need to resend them?
So there are ways, in this example that I haven't actually shown, but there's ways you actually want to know if messages were consumed. There are ways do AX and NAX. So if there's that kind of dependency, and take a look at the Watermill API to kind of, there are use cases where they show you how to do that.
Okay, I think that's the last of the questions. Do you want to try to do a quick demo before we wrap up?
Sure. Yeah, and it really, like, if you set up, like, follow the instructions, it's as easy as running a command, as I show here. So let me go ahead and share my command line.
It's a way to tempt fate at the end, Prema, doing a live code thing and saying that it'll be straightforward. You never know.
You never know, right? So here on the first tab, like the top tab, I'm going to actually run the application, and then the bottom tab, I'll run a select query from against that Postgres container to see if the record got inserted. And so hopefully, if this works, all I have to do is Docker compose up. So there you have the database connection set up.
All right, well, as this is running and kind of showing what's happening, are there any final questions in our last couple of minutes here together? Keep in mind that you're also welcome to just, reach out and email us questions after the fact. If you want to ping us about anything that we demonstrated or that Prema talked about. If you need to think about things a little bit, but then we can see the data coming through. Let's see, temperature 73.9, feels like 76.6, humidity 60, partly cloudy.
And so you notice, like, all these subsequent calls that found existing record in the database, but you can see that first time the record got inserted. And this is kind of like the reason, like, why I also said that that's why, like, we want to do this check, right? So we got these messages like several times from the API, but the data hasn't been updated yet. And so that concludes the demo.
Very cool. Let's see, we got two more quick questions. Is Ensign only for JSON data, or can you put any data into Ensign?
So it does support multiple data types.
Yep. Yeah. So JSON data is supported. Basically any of the common MIME types. So I don't know if the question asker is familiar with MIME types, but the idea is that any of the standard MIME types are supported, but probably a lot of public data APIs are going to have XML, JSON type data. So I'm guessing that this is the person who's thinking about maybe building something internal, like an internal API. And the answer is you don't have to use JSON data if that's not your use case. But great question. And then final question: can you explain the Marshall function one more time? And that's actually very related to the idea of what kind of data can you use. So if you want, Prema, I can take this one. Basically, marshal and unmarshal is a way to, it's like a way to open a piece of data, right? And so when you want to send a piece of data along the wire, you have to turn it into a string, basically. You have to serialize it. And then you can send that string down the wire. And so when you send it, you've got to marshal it. And when it comes back, you have to unmarshal it. You have to turn it from a string back into a piece of data that you can consume. So hopefully that kind of answers the question, but great question. All right, we are at the end of our hour. So I think we are out of time, but Thank you all so much for attending. Thank you so much, Prema, for your excellent tutorial. This was great. You didn't mention all of the work, I'm sure, involved in actually wrangling a public data API. If anybody has experience using public data APIs, they're kind of can be a little temperamental. So, but it's free. So I guess you get what you pay for. But thank you so much. Thank you all for attending. We will be in touch sometime in the next day. We are actually going to schedule a follow-up tutorial that's about an introduction to distributed systems, assuming you don't know anything about distributed systems, but you know a little bit about the Marvel character universe. So we hope that you'll join us for that one coming up in a couple of weeks here. Thank you.
Thank you all.